Hello everyone, welcome to the session on system software. We are in module 2, that is assemblers. So in the last session just we had a discussion on some of the machine what independent assembler features like literals, symbol defining statements and what expressions and all. So now just I'll move to that program blocks. So as we know that so far what is the main task of an assembler, which is used to convert what assembly level language code into machine code, right? So for doing that one, just it has to generate an object code for each and every instructions of that program. So then it is going to making an object file for that particular program for the loader to be loaded into the primary memory. So so far just we have seen the complete program as a single unit. So but the assembler is also having some of the features. It is going to treat the same program in different ways. So how actually it is going to treating that program in different ways? So for example, when we are taking any kind of assembly level language program, so it is having different kinds of data, isn't it? So means it is having a set of instructions and it is also having the set of the memory variables or data variables which we are using in that program. Again, it is also having some kind of larger space or larger memory variables like that. So means one of the feature of an assembler, it is going to treat all the different kinds of whatever the different kinds of data are there in different way. So means whenever just we have written that program previously, so just it is going to scanning that program line by line. So for that just it is going to generate an object code. So but in this, by using that program blocks, so there are another two machine independent features are there. One is program blocks and another one is control sections. So we'll discuss that control section in the later session. In the program blocks, what actually it is going to do is, it is going to divide that program into different kinds of blocks. In different blocks, in each block it is having only one kind of information. So as we know that a program, it is having different kinds of data. It is having set of instructions, it is having set of data variables which we are using in that program and the larger memory in that particular program. So what actually it is going to do is, it is going to keep the instructions in one block and it is going to keep the data which is in another block, and whatever the larger memory which is there, it is going to keeping all the larger memory data in some other blocks. So whenever the loader is loaded, then it is going to generate an object code in the sequential manner only. So just it is whatever the block which is having only that instructions, it will be at the top of that one. So then whatever the memory variables we are using, so then the larger block of the memory come at the bottom of that particular program. So whenever the assembler is generating an object code, yes, of course all those are going to be organized in the sequential manner only. So then it is going to generate an object code for that particular program. So in this case, so means it is going to divide that program into different kinds of block. Each block it is having different kinds of information. One block it is having only that set of instructions, another block which is having only the data, and another block which is having the larger memory which we are using in that program. So means the program blocks, it allows the generated machine instructions and the data to appear in the object program in different order by separating the blocks for storing code, data, stock and larger data block like that. So means, so just we are going to reorganizing the program what the user has given. Just it is going to reorganizing that kind of program into different kinds of blocks. So for such kind of things, it is using an assembler directive like use. So just it is using an assembler directive use. So means to mention that block name. So whatever the instructions means, just it is going to mentioning this instruction, it should be belonging to this block. So for such kind of things, it is using we are using an assembler directives, it is use. So use assembler directive which is followed by that block name. So sometimes if you have not mentioned, that use assembler directive in anywhere of that program, so then it is going to thinking that the entire program is a single unit. Suppose if I am using that use assembler directive, so then it is going to create different kinds of blocks for that particular program. Suppose if you have not mentioned that use assembler directives at the beginning of the program, so by default it is going to be considered as the default block. Suppose if the use which doesn't have any what block name here. So by default it will be what taking the default block for that one. So in the default block always we are storing that set of the instructions. As we know that while we are writing that assembly level language program, first we are writing the set of instructions, then which is followed by whatever the data variables which are required for that program. Just we are defined such kind of things at the bottom of that program. So means for creating the blocks, just we are using an assembler directive. It is use which is followed by the block name. So if it is not having the block name, by default it is going to be considered as that is the default block. So for example, so this is the program which is there in your textbook. So this program, just you can observe that at the starting of that program, so here we have not mentioned that use assembler directive or any other block name here. So means by default what actually it is going to thinking is, so whatever the first block is there, so it is going to consider that first block, it is a default block. It is going to consider as default block. So means it is going to copying all the instructions until it encounters the use assembler directive in that particular program. So means just it is going to scanning all the instructions from the line number 5 to line number 70 up to jump at the return address at the rate return address. So at the line number 92 it encounters what? The use assembler directives. So until that one, so then it is going to copying all the instructions in the default block. So this is called as default block. So this is the block 1. This is the block 1. So next at the line number 92 it encounters that use assembler directive which is having the block name, it is the C data. So means another block name it is there. So what is the name? It is C data. So means it has to keep whatever the instructions which are there until it encounters another use assembler directive. Until it encounters another use assembler directives, it is going to keeping all these data into that C data block. So means another data block, it is C data. So that is the block 2. So at the line number 95, whatever the instructions which are present at the line number 9500 are going to be copied to this block, and at the line number 103, when it reaches to that line number 103, it got one more use assembler directive here. One more use assembler directive. So means it is having, what is the block name? It is C blocks. C blocks. So this is the third block which is having that one. So means it is going to copying all the subsequent instructions or all the subsequent data within that blocks until it encounters another use assembler directive. Where actually it is there? At the line number 133. At the line number 123, it encounters another use assembler directive. It is not having any kind of block name here. It is not having any kind of block name. Again it is going to copying all the instructions to the default block only. It is going to copying all the instructions to the default block only. So till line number 185. So because all those are instructions which are required to perform a specific task. So means it is going to copying from here to here, from this instruction to this instruction, it is going to copying all these instructions to the default block. So next it is going to encounter that another use assembler directive which is followed by what? The data, that block name, it is the C data which is already there. Again it is going to copying the subsequent data fields, what subsequent instructions which are present after this use assembler directives to this block. So next after that at the line number 208, again it encounters another use assembler directive which doesn't have any kind of block name here. Again it will come to the default block only. It come to that default block. So then it is going to copying all the instructions until it encounters another use assembler directive here. another use assembler directive. So means it is going to copying all those instructions into default block. So once it encounters that what use assembler directive here, so again it will go to that what C data. So after that it is having only that LTORG. LTORG is nothing but it is having the literals. It is going to creating that literal pool. So means whatever the literals we are using or we are using in that particular program, so every literals will be present in that LTORG statement here, right. So after that whatever the literals we are present which are present in that LTORG statement or LTORG assembler directives, all those literals will be enter into that C data block. C data block. So then it will encounters that end assembler directive. So means it is going to processing that one. So means for this program it is going to create 3 different kinds of block. That is a default block which is having only that set of instructions of that program. Again the C data which is having the data variable and the literals which we are using in that program. And when it comes to the C blocks, you can observe that in the C blocks it is having only that the maximum length of that what instruction, what is the maximum length. So means it is having only that buffer area here. So for these kind of things it will not store in the deep blocks, C blocks. So only that buffer variable will be stored in that what C blocks. So what is that buffer? Is the maximum length or the buffer area which required for storing the data after reading the record. So this is about that program. So by default for that just it is going to assigning that block or block number for each the block or program blocks here. For the default block the number it is 0. For C data the block number it is 2. For C blocks the block number it is 2, like that. So just it is going to assigning that block number. So for example for the same program, so just you can observe that he has mentioned the starting address as 0. So means the program will be started from the memory location 0 only. The program will be started from the memory location 0 only. So means yes, of course it is going to be started from this memory location 0 0. So just you can observe that whatever the second column is there, it is the what block number which we are using here. The block number, then which is followed by the label field, instructions and what mnemonic field and the data field and whatever the object code which is being generated for that particular program. So just you can observe that. So whatever the instructions which is there from the memory location 0000 to 0024 are belonging to that block number 0. What is the block number 0? What is the block number 0 it is? What is the block number 0 it is? Default block. The default block it is having all the entries of the instructions which are present in that program. So next is, so again the next block just you can observe that. So what will happen during pass 1 and pass 2? So just I will explain what will happen during pass 1 and pass 2. During pass 1, so for every block, so the 3 blocks are there. 3 blocks are there. So this is the default block. This is the default block. So this is the C data. This is the C blocks, isn't it? So this is the C blocks. So means every what location counter value, the locator counter value for each and every block will be started from 0 only. Will be started from 0 only. So this is the block number 0, this is the block number 1, this is the block number 2. So means it will be started from 0 0 by default. So whatever the first default block is there, so means it is going to be stored the data from 0 to 0024. So means it is going to copying that 0 0. So just it is going to copying all the instructions from 0000 to 0024 for this instruction. So next what will be the program counter value? So in the next value we have to take, so what is the program counter value? It is 0027, because since it is SIC program, SICXC, so means whatever the instruction is there, so all the instructions it will be at the what format 3 only. Just I will tell why we are taking that format 3 only here. So program counter for the next memory location, it is going to be incremented by 3. So means the program counter value is 0027. So once it encounters that use assembler directive here, then it will move to that next block. So means it is going to saving all the states of this default block. So then it is going to switch over to that C data block. It is going to switch over to the C data block. So C data block, again the program the program counter value or the location counter value, it is going to be set as 0. It will be started from 0 memory location only. So means it is started from 0. So next it is started from 0 till 003. So 0003. So next, what is the next program counter value? It is program counter value, it is 00006 for this one. So again at the line number somewhere else it encounters another use assembler directive. Again the third block is also started from the memory location 0 only. Third what block is also been started with 0 only. So means 0 from, what is the length of that one? It is 1000. What is the length? It is 1000. The C blocks it will be started. So the length of this one, it is 1000 like this one hexadecimal value. So again when it comes to this one, again it will encounters another use assembler directive with no block name, means the default one. So again whatever the default block is there, so again whatever the instructions which are present in that after that use assembler directive, whatever the instructions are there, all the instructions must be copied to the default block only. Again it will be resumed from the memory location 0027, just you can observe that. So from the memory location 0027 it is going to copying until 004A. So until from 0027 to 004A, again for the next instruction what will be the program counter value? Plus 3. A plus 3 is nothing but 10 plus 3 it is 16. 16, so 10 plus 3 it is 13. 13 means it is D. So means what is the next instruction? The program counter value it is 00004D. So again it encounters that use assembler directives at the memory location again 0006. So again it is going to copying that what is the next instruction which is there. So still it is 00, then it is having only one data variable, that device name. So means it is going to copying that instructions at the memory location 0006. So what is the next program counter value? It is going to be incremented by 0002, 0006 to 0009. So after that again it will encounter another use assembler directives. C blocks it is only this much. Again it encounters another use assembler directives, that is the again it is default block, from where actually it is going to resuming from the memory location, because it is going to saving all the program counter value and the process states and block states of that particular program. So means again it is going to resuming from the memory location 004D only until to the memory location 0063. So just you can observe that 0063. So next what is the program counter value for this? What is the program counter value? It is 0066 for the next instruction. Again it will come to that. Again when it encounters that 0007, again use C data is there. C data block is there. It doesn't have any value for that one. So means it will be ended at the memory location 0007 only, because it doesn't have any value for that. Again 007 at the memory location 000A. So after end only, after end of that program only, before that end program only, whatever the literals which are present in that program, it is going to be defined in that literal pool. Once it encounters that LT statement, it is going to be copying to that particular thing. So means the C data block is also having the data which are present at the memory location 0007 and 000A till 000A. So means 000A. So next it is encounters that end assembler directive. So now the program counter value for this block, it is 000. A plus 1 is nothing but it is B. So means here whatever the current value of that program counter is there. What is the current value of the program counter for the default block? What is the current value of the program counter? It is 0066. What is the current value of the C data? It is 000B. What is the current value of this C block? It is 1000. So means these values are nothing but the length of the blocks. The length of the blocks. So what is the length of the block, default block? It is 0066. What is the length of the C data block? It is 000B. Only that much of information are there in that particular block. And what is the length of that C blocks? It is 1000. So this, whatever the current value which is there for each and every block, so that will be considered as that block length. That is the block length. So when it is, once all the blocks has been created, so then it is going to reorganizing that program in that manner only. First it is going to copy, so that first it is going to placing that default block, so which is followed by that C data block, which is followed by the C blocks block, like that. So whatever the current value is there of the program counter for each and every block, it will be considered as the program block's length. So here this is showing, so means from this memory location to this memory location is block number. What is the block number? It is 0. What is the block name? It is the default block. So from 00 to 003, so means each and every block will be started from the memory location 0 only, from 000 to 003. So then it is the C block, C data. Again from the memory location 000 to 1000 is the absolute value, that is the maximum length, that is the larger area which we are using in that program, that is the buffer area, will be placed in that C blocks. So again it will be again from this memory location to this memory location, again it will be in the default block, again from this memory location to this, again it will be in C data block, and from this memory location to from 0060, again it is there in the default block, from 0007 to 000A, 000A, so means it is there in the C data block. So this is how actually we are going to representing that block number along with an address. So means again for this one only, so how actually it is going to calculate what the target address. Just you can observe that in this program, you can observe that there is no, so only that instructions which is at the memory location 002D, for that instruction only it is in the form of format 4. So all other instructions in the previous example, in the previous session what we have discussed, so means the J sub instructions what we are using in that main program, all the J sub instructions in the format 4. So but in this case all the J sub instructions are in format 3. So why? Because we are pushing that larger block memory or larger memory space at the end of that program. So actually is going to organize this data means in that memory. So it is going to organizing like this. So means it is being started from 00. From 000 to 00662, it is having that default block. So means all the instructions will be here. From 0, the next C block will be started from the memory location 00662, 00662. So what is the length? That is the plus B. Plus B means B plus B is nothing but is 11. 11 plus 6 is 17. 17 means it is 1, 2. So means 2, 7, 0, 0. So means 1, 2 is nothing but 17. It is 1, 1, right? So 0071. From the memory location 00662, 0071. So the C data will be there. C data. So means just we have to add the length to the last memory address of the previous block. So then we will get the memory of that. What is the length of that? This one. What is the length of this one? So then what is the length of this one? 000B. So if I am adding that, it is been started from the memory location 0006, 0066. If I am adding the length of this one, so then I will get that memory space for that C data. So next, what is the length of the DC blocks? What is the length? It is 1000. From 0071 to 1071, C blocks will be there. C blocks will be there. So this is how actually the data is going to be organized in the memory. It is going to be organized in the memory. So means during pass 1, actually it is going to do is a separate memory counter or location counter for each program block it is maintained. So means each block will be started from the memory location 000 only. So when it is switching over from one block to another block, so means it has to save all the values of the program counter or the location counter value of the previous block. So means A separate location counter for each program block is maintained. Save and restore the location counter when it is switching between the blocks. So means we have to store and save and restore. Save and restore of that process states. So at the beginning of each block, so we have to set the locator counter value as 0. So means for each block, the starting address of that each block, we have to set the location counter as 0 here. So next, after that, we have to assign each label and address relative to the starting address of that program. So means here only, so just we have to, when the symbol table has been created during pass 1, it has to enter the label name along with the block number and the block length and the starting address of the block. Everything should be there in that symbol table. So means store the block name or block name number in the symbol table along with the assigned relative address of that label. So for example, so in that particular program, so what is the instruction which is there at the memory location 0009? So what is the instruction is there? Comparison with an immediate value. So means it's been started with 00 only. So means it is there. So instead of that one, so what we can do is, just I am taking another example at the memory location 006. So what is the instruction is there? Load accumulator with length. So but what is the length which is required for this instruction, where actually that length is there? Where actually that length is there? In the C data. In the C data block. So which is at the memory location 003, because all the blocks are independent here. So when it is loading into the primary memory, then it is going to be loading like this, right? So means is at the memory location length. So means what is the starting address of the C data? It is 0066. What is the relative address of the C data? The length in the C data? It is 0003. So means here, so means store the block name or number in the symbol table along with the assigned relative address of that label. So what is the relative address of the length? It is 0003. So during pass 2, it will get this address along with the starting address of this block name. So then it is going to calculate the actual address for that one. So just I'll take an example, I'll explain for that. So after that, indicate the block length as the latest value of the location counter for each block at the end of pass 1. As I said, so the current value, what is the latest value of the location counter is there. So it will be considered as the block length. It will be considered as the block length. What is the block length of the first default block? It is 0066. What is the block length of the second C data? It is 000B. What is the block length of that C blocks? It is 1000. So means it has to be saved as the what? That block length. So assign to each block as the starting address in the object program by concatenating that program blocks in a particular order. Just we are going to concatenating this program blocks in this way. So in the particular order. So this is how actually we can process that program into number of blocks. Program blocks by using an assembler directives use. If you are not using assembler directives, then it is going to consider that entire program as a single unit. So during pass 2, what actually it is going to do is, during pass 2, just it is going to calculate the address for each symbol. It relative to the start of the object program by adding the location of the symbol relative to the start of its block and the starting address of this block. So for example, of course, just I'll take the same example. Means in this case, just you can observe that. So there are 3 blocks are there: default block, C data blocks and C blocks. So block number for the default it is 0, C data it is 1, the C blocks it is 2. So what is the starting address of the default block? It is 00. What is the length of that one? 0066. So when I am adding the starting address and the length of that one, so then I'll get the starting address of the next block. So means 0066, it is the starting address of the C data. It is the starting address of the C data. When I am adding the length to this starting address, when I am adding this length to this starting address, so then I'll get the starting address of this C blocks. So means B plus 3 it is 1 1, so means 7, so 0 0. So what is the starting address of the C blocks? When I am adding this, so when I am adding this to this, I'll get the starting address of that one. So what is the length of the C blocks? It is 1000. So if I am adding that is 0071 plus 1000, then I'll get the starting address of the some other block which is if it is present like that. So means in this case, so means along with the symbol table, it is also saving that the block name, block number, address and the length of that program also. So if you want to find out how actually it is going to generate an object code here. So for example, so means just I want to get an object code for this. How actually it is going to calculate an object code for this instruction. So means load accumulator with that length. So means as we know that, so is at the block number 0, what is the memory? It is at the memory location 0006. Is at the memory location 0006. So I want to get an object code for this instruction. How actually I can get? So whatever the length which is seeking for that length which is present in this C data, isn't it, in the C block 1. So where actually that length is there? Where actually the length is there? In the block number 1. What is the relative address for that one? It is 0003. So means whatever the length which is required, so it is in the default block. It's been started from the memory location 00002 0066. 0066. So means in the C data, whatever the length which is seeking for this, it is at the memory location 0003. So means 0003, what is that length is there? What is the length? Length is nothing but it is a reserve word. It is the reserve word. So means what is the starting address of that C data? This is the C data block. The relative address of the C data block, it is 0003. The relative address for that C data, it is 0003. So what is the starting address of the C data? It is 0066. So means I want to assemble, yes of course, whatever the blocks which has been created, all the blocks are going to be organized in the sequential manner, one after the other. So means to get an address for this, how actually it is going to calculating? So means it has to find out the target address is equal to displacement plus the program counter value. Displacement plus the program counter value means I want to find out the target address here. According to that one, so means when these blocks are organizing like this, so the relative address of that C data block, it is 0003. At the memory, where actually it is there? At the memory location 0069. 0069 is at the memory location 0069. What is the target address? It is 0069. So means it's been started with 0066 plus 3. So then it will be stored at the memory location 0069. What is the target address? It is 0069. Just I want to find out the displacement value. So what is the displacement value? Sorry, what is the target address? It is 0069. What is the program counter value? What is the program counter value? So means it is pointing to this instruction, it is fetching this instruction. So next the program counter value, it is going to be pointing to the next instruction. What is the program counter value? It is 0009. So then what is the displacement value? Displacement is nothing but 0060. So when that instruction needs to be assembled means whatever the displacement value which is there, that is the 060, just we have to take. So means in the format 3, so means in this case NIXBPE. So what is the opcode for LDA? It is 0, 0. And what is the, it is not index relative, yes, of course it is not base relative, yes, of course it is program counter relative, but it is in format 3. So what is the displacement value? It is 0036, just I am taking an hexadecimal value. So since it is direct addressing mode, just I have to make it as 11. So just I have to change that one value, just I have to get that value 03206. So this is an object code for this instruction. It is 060, right? 2060. So this is an object code for that instruction. So means in this way, for each and every instruction, just we have to find out the target address or the object code in this way only. So because all the blocks are going to be arranged in the sequential manner one after the other, so means if you want to calculate, so means you can observe that, So what is the how actually I can find out the target address? What is the starting address of the C data block? It is 0066. What is the relative address of that one? 0033. So means when I am adding these two things, I will get the actual address of this length in this memory. So here in this way just we can calculate that what object code for that one. So one advantage is why we had go with that format 4 in the previous example. So just because of that larger memory which occurs in between that program. So means it gives the 1000 bytes space from main routine to subroutine. So means when it jump to that subroutine, so means the displacement value, it is more than that of the 4 digits. So to avoid such kind of things, just we are going to moving that larger block of the data at the end of that program. So means in this case, so no need to go with that format 4 instructions or format 4 instruction format here. So just we can do we can assemble all the instructions by using format 3 only. So just you can observe that. So in that case, so program readability, no extended format instructions on the line number 15, 35 and 65. So whatever the instructions which are there in that particular lines, it is J sub instructions. So means we are moving that larger memory into the to the end of that program. So hence no need to go with that format 4. Instead of format 4, just we can go with format 3 only. So then we can avoid that relocation, or we can avoid that modification for such kind of instructions, because only the instructions which are there in the format 4, only for such kind of instructions the modifications are needed at the loading time. So if it is having the displacement value, no need to do any kind of modifications for that kind of instructions. So no need for base relative addressing mode. So because everything is going to be done at the program counter relative addressing mode only, so then only just we can use the program counter relative addressing mode. So LTMORG is used to make sure that all the litters are placed ahead of any large data areas. So means just it is going to place all the litters which we are using in that program, so in that C data block only. So it is not necessary to physically rearrange that generated code in that object program. So means, so just we can rearrange that code, so as actually that program is appears like that. So means in this way just we can create the object code for that program blocks and all. So here just I want to, so program blocks is nothing but logically it is going to dividing that program into different kinds of blocks. Each block it is having one kind of information. So all the blocks will be organized in a sequential manner one after the other. So this is all about that program blocks. So in this session just we have learned how actually the assembly is going to create different kinds of program blocks and all, how actually is going to handle to create an object code for such kind of program blocks and all. So I am going to winding up this session now. So we will come up with that control sections concept in the next session. Thank you.